So I want to start talking about what makes up the real number system. In other words, I want to look at all the little nuances that go along with the real number system. So the cool thing about it, just ask yourself, what's real? And eventually we're going to say, well, what's missing as we go along in this particular unit? Check this out. Really, really cool. For example, go to see a little kid. When you go see a little kid and you ask them, can you count for me? And they'll go, sure. 1, 2, 3. Interesting how little guys will turn around and start counting at 1. And they'll go up by whole numbers. They'll go 1, 2, 3. They don't start counting at negative a half. 1, 2, 7, 4. They don't go that way. They start at 1. And surprisingly enough, they do that naturally. That's why the first number system is called the natural numbers. They're, in fact, counting numbers. Start to count. Look, 1, 2, 3, 4, and so on. Isn't that cool? Awesome. And they do that just naturally. So now ask yourself, what's missing? Well, a 0, of course. Well, what's the importance of 0? A 0 tells you you have nothing left. You start with nothing. That's important. So obviously, 0, yeah, guess what? Look what's missing. It's missing a 0, and the 0, doesn't a 0 look like a whole? That's why they call them the whole number systems, because you got 0 and 1, 2, 3, 4. So in other words, you're including all the natural numbers now, but now you start at 0. 1, 2, 3, 4. You see what happens? Aha! So now you ask yourself, well, what's missing now? Well, why did the zeros come about? The zeros came about because of money. You have no money, or you have no debt, or you have nothing left to sell. You needed a 0 in there. But what happens when you have a bunch of money and you overspend? Debt. You got it. So guess what happens next? A system called the integers. And if you think about it, the integers contain all of the natural numbers, 1, 2, 3, 4. The integers contain a 0, but they also now have negative numbers. And these negative numbers, in fact, mean that you owe money. Isn't that interesting? So look, there's all the naturals. There's the whole numbers, but now you got some negatives. You got some integers happening. And the integers, in fact, like I said before, represent debt. Oh, isn't that cool? But most importantly, about integers, you have to remember one thing, that there are no fractions here, absolutely not, okay? And no decimals either. So these guys are whole numbers, just like the whole numbers and the natural numbers, just have negatives in front of them, okay? No fractions, no decimals. So if somebody comes along and says, oh, I have an integer of a negative a half. No, you don't. That's a fraction. You can't have a fraction integer. Okay, so now think about it. Remember the question? Ask yourself, what's missing? So obviously what's missing? Fractions. Yup, so let's bring those guys in there. Fractions are known as rational numbers. Aha, so what do the rational numbers include? The rational numbers include everything. They include all the natural numbers. They include all the whole numbers. They include all the integers, but what are they? They are, in fact, fractions and decimals. Ah, okay. So if they're fractions and decimals, think about this. Fractions could be like 1/2. But I know what you're saying. Well, wait a second. If rationals include natural numbers, how can a natural number be a fraction? Easy. 2/1. Any number in the world could be made into a fraction by putting it over 1. Ta-da! So in fact, all the naturals, yep, they could be made into fractions. All the wholes are fractions. All the integers are fractions. But look at the other definitions here. Something called terminating. Terminating what? Terminating decimals. So what are you talking about? Something like 0.5. Ah, well, isn't 1/2 when you divide it and put it into a decimal form just 0.5? It is. But what about those ones that are like 0.3333 and on and on and on and on, and they never end? Well, those are called repeating decimals because they have a definite pattern to them. Those are also included in the rational numbers. Cool, right? But what about those ones that don't have a pattern? What about those crazy ones that never end, have absolutely no pattern to them? So they're non-terminating, non-repeating, no patterns. Well, that sounds a little crazy, doesn't it? Yeah. Well, that's what brings up this category. Dun, da, they're a little crazy. Oh my goodness, they're irrational, aren't they? Got it? Aha. So, means no pattern to them. They never end. Think of the best number in the world. Oh my goodness, the one that has no pattern, never ending. Every March 14th, they have it. Yes, everybody's favorite, pi. There it is, pi for sure. And the neat thing is it says you cannot write this as a fraction. Yeah, no kidding. I know some people use some sort of crazy fraction for pi. That's not accurate. That fraction, I think it's 22 over 9 or something like that, or 22 over 7, whatever it is. I don't even remember it because it's not accurate. That's not pi. Uh-huh. Well, what about the other numbers out there? Well, some other numbers, some other examples would be something like root 2. The other one would be root 5. Okay? But I know what some people are saying. Well, how about the square root of 4, sir? That's got a square root on it. Well, whoa. If you take the square root of 4, isn't that 2? Doesn't that end? Yes. Guess what? That's a natural. Oh, I see. So what do I do in a situation like this? How can I tell if something is irrational? Throw it on your calculator. Watch. Let's put a couple of these in here. Oh, let me clear that out here. For example, second square root, 2. Punch it. Yoink. You got 1.1421356. That looks like it fills up the entire display, doesn't it? Guess what? That's it. That's irrational. Look at this one. Even if you got something like second square root of 5, punch it in there. Look at that. I got 2.236067977. Now, I know what you're saying. Sir, look, it's starting to repeat here, isn't it? Not really, because you got to remember, that's the end of display of your calculator, and that number is probably rounded. This end number is probably a rounded number because your calculator doesn't show all of the values going on and on and on here. So that number could be rounded. I always say if it fills the display and there's no pattern to it like that, definitely irrational. See how it works? Perfect. Now, here's the cool thing about all of these numbers. You see how all of them are all surrounded by this black circle here? That means they all belong to a group, and you can kind of see the word sticking right here. That, ladies and gentlemen, is the definition of the real number system. So the real number system contains all the natural numbers, the whole numbers, the integers, the terminating numbers, okay? Those are our rational ones, and the irrationals. All of them are part of the real number system. See it? Woohoo! Right there. Now, I know what you're saying. Gee, if I was given a question, sir, on an exam, would I have to write the whole word natural numbers? I'm not a very good speller, you know. Well, guess what? Neither am I. I'm a math guy. I'm not a spelling guy. Anyways, how would you remember this? Real simple. Natural numbers, they give it the symbol. N for natural. Woo, that was tough. Can you figure out what symbol they'd give for the whole numbers? Yep, W. Oh, for sure. Whole numbers are called W's. How about integers? All in favor? I. Okay, but check this out. What are they going to give the rational numbers? Now, I know you're probably saying, well, probably R. The real numbers have the symbol R. Aha. So what do you get the rational numbers? Surprisingly, Q. Huh? Yes. Q stands for rational numbers because Q actually stands for quotient. Yeah, it stands for quotient, which means if you think about it, look at this. How did you convert this fraction to a decimal? You divide it. That's what a quotient is. Aha. So what do they give irrationals? Think of the word irrational. It means that they're a little, nutso. They're out there. Okay? Irrational. So think about it. I always say, take somebody who is rational, take them to a bar. They become irrational. Q bar. That's how it works. Okay. So enough of that one. When we get into some more podcasts right away, we're going to get a little bit more detailed, and I'm going to show you some really cool tricks. But at least now, you know what a real number is. Copy.